After 5 minutes of drying in the oven, we're going to measure on a tiered scale. And the mass now is 32.60. This is the mass of the filter paper. I'll take a picture too. This is the mass of the filter paper, watch glass, and sample. So 598. That's the number that was recorded. And we have the mass of the product. We also need to measure the melting point of the product. But I can take a picture of the thermometer as it starts melting, with the initial melting and the final melting, and I will provide the picture of the melting process for you. So I use the 2-chlorotoluene for this experiment. 2-chlorotoluene, when it changes to when it's oxidized, it would change to the 2-chlorobenzoic acid. Melting point is 138 to 140. The reason I want the melting point, I want to know the melting point, because the setting on the melting apparatus is based on the melting point or expected melting point for the product. If the compound is melting between 100 and 150, the proper setting for the power regulator would be around 4, because we don't want to heat up the sample too fast or too slow. So I'm going to grind this sample, and to grind the sample so it will fit into the capillary tube better. If your sample doesn't need to be grinded, you don't have to, but just to make sure that it will get into the capillary tube faster, I can grind using the device or just the weighing paper or filtered paper. After you tap the capillary tube with the open end into the sample a few times, some of the sample gets into capillary tube, but in order to bring it all the way down, you pass it through a hollow glass tube. Do that a couple times to make sure there is no air trap within the sample, and the sample is like solid piece, like continuous. There is no, it's like one piece. Because air is not good conductor of the heat, and we cannot have air trapped there. We place the sample in the capillary tube into the sample holder, which is a rectangular small opening next to the thermometer holder. I hope you can see, and if not, you just trust me. There is an opening here with the rectangular opening. It can take up to 3 capillary tubes, but we are only using 1. We turn on, and we place the setting at 4. We adjust it at 4 and wait, monitor the melting process through the magnifying glass right here. And as soon as it starts melting, we record the initial melting. And when the entire sample is melted, we record the final melting temperature. Now, the initial melting would be temperature, which in that temperature, the samples, it starts like changing to liquid. So when you see drop of the liquid, be careful not to record the temperature of condensation. So in other words, if you see liquid about the sample, let's say the sample is up to here, and you see condensation or sweating of the capillary tube on top of the sample, that's not initial melting. Initial melting would be when you actually see the liquid in the sample. So the top of the sample would start forming liquid. You record the initial. When the entire sample is melted, you record or as soon as the entire sample is melted, you record the final melting. You want to make sure that record it as soon as entire sample is melted, because if you wait too long, there is no difference between hot liquid or cold liquid. So it's not going to change. The difference is between solid and liquid. So as soon as it turns from solid to liquid, you have to record the temperature and don't give enough time or extra time for thermometer to show higher number. So I know that the melting point for this compound, I'm just hoping that it would melt at approximately melting point of a pure sample or close to it, which is 138. So that's why I'm just talking. If it was an unknown, I would have to do a quick melt and monitor it all the time because I don't know at what temperature is melting. This is a known sample. But your data, how close the melting point is to the literature value, it shows how pure your sample is. So if the sample starts melting at 100, that means your sample is impure or you didn't dry it long enough. So we're just waiting for this, and I can pause the video and show you when it's actually melted. I don't know how long it's going to take.